I'm Zack from Kid2Kid Tutorials, and today we're going to be practicing the Pythagorean Theorem. So let's start with our first problem here. So we have letter A says to prove that a squared equals cd. B says to prove that b squared equals ce. And C says to show that a squared plus b squared equals c squared. So given this triangle. So we start on A, which says to prove that a squared equals cd. To do that, we need to find the corresponding sides. And to make that easier, we need to rotate and flip the triangles to make the sides correspond. So we will demonstrate that down here. So this is triangle BDC. BDC. And that is, and then on the right is triangle BCA. So now it's a little bit easier to see the corresponding sides. So now we take the corresponding sides to prove letter A. So to prove A. So we have corresponding sides AC and D over A. Because A is the hypotenuse here, and C and D both make the hypotenuse here. So we write A divided by C equals D divided by A, lowercase d divided by lowercase a. And then we can simplify that to A squared by cross multiplying A squared equals CD. So we multiply these two A's here and C and D. So we prove that A squared equals CD. So let's get started on our first problem. We're asked in A to prove that A squared equals CD, and B says to prove that B squared equals CE, and C says to show that A squared plus B squared equals C squared, given this triangle here. So in order to prove this, to prove A, we need to find the corresponding sides. And to make that easier, we need to find the triangles that match up to each other. So we go down here, and right here we have BDC and BCA here. So now we find the corresponding sides. Lowercase a is the hypotenuse, so lowercase a divided by lowercase a divided by, so this whole hypotenuse here is C. So E and D added together is C. So A divided by C, which equals and D over A. So this here over that. And then that can simplify too by cross multiplying A times A, which is A squared. So A squared is equal to C times D is CD. So we have A squared equals CD. Now for B, we're asked to prove that B squared equals CE. So let's go to the triangle that shows these matching up. So scroll down. ADC, triangle ADC, and triangle ACB. So now let's find the corresponding sides. So we have E divided by B right here. E divided by B. And then we have B, which is the hypotenuse, divided by this hypotenuse, which is C. So B divided by C. So lowercase e divided by lowercase b equals lowercase b divided by lowercase c. And then that simplifies to, we cross multiply again, B squared equals CE as our answer. Now we're asked in C to show that A squared plus B squared equals C squared. So we know a squared plus b squared. We write a squared plus b squared equals c squared, but we don't know that yet. So we write cd, so a squared, remember we proved that was equal to cd. And then, so a squared plus b squared equals cd plus b squared was ce, so plus ce. So a squared, which is cd, plus b squared, which is ce. So now we can take the c out, because we have that in both cd and ce, and you get a squared plus b squared. A squared plus b squared is equal to c, parentheses, around the d plus e. So d plus e inside the parentheses. And then we remember what d plus e is. So we have a d here and an e here. And then if we add those, we get c, because this line right here, this line segment right here, and this line segment right here is the whole thing c. So d plus e is equal to c. So we have a squared plus b squared is equal to c squared, because c times c, since d plus e is c, we have c times c, which is c squared. So now we've shown that a squared plus b squared equals c squared. So we're starting on our second problem now. So we're asked to find m and o. So given that mn equals no, which equals 7, so both mn and no are equal to 7, and mo equals 10 right here, equals 10. So to find m and o, we need to find the altitude, which is, we can use that to find the area. So let's find the area. So to do that, we need the height. So we put a line in the middle here, and that will be the height. And since we put that line in the middle, we split this here, so erase the 10, and we put a 5 on both sides. And we call this point here x. So we're trying to find nx to find the area, which finds m and o. So to do this, the Pythagorean Theorem allows us to write mx squared plus nx squared equals mn squared. And then we plug in the numbers for these. So we know mx here is 5, and 5 squared is 25. So we write 25 plus nx squared, which we don't know yet, so we still write nx squared, equals mn squared. So mn is 7, so we write 7 squared, and 7 squared is 49. So 25 plus nx squared equals 49. So now we have two like terms here. So we subtract 25 from both sides, and we get nx squared. Subtract 25. And we have nx squared equals 49 minus 25 is 24. And we haven't found nx yet. We have nx squared. So we need to square root both sides to get rid of this squared. And we have nx equals, we can simplify the square root of 24 to 2 times the square root of 6. 2 times the square root of 6. Okay. So now we found nx. To find the area, we need the height times the width. So we divided by 2 since this is in triangle. So we write MNO is equal to the height, which is nx squared, which is 2 times the square root of 6. 2 times the square root of 6, and then times the width, which is 5, the width, which is 5, and divided by 2. And we have, well, times 10. The width is 10. Not 5. Sorry. So times 10. So we multiply the like terms up here, which is 2 and 10. We can't multiply 10 times the radical of 6, the square root of 6. So we have 2 times 10, which is 20, times the radical 6. And then we divide that by 2. 20 to the power times the radical 6, or times the square root of 6, divided by 2. So we divide the like terms, which is 20 and 2, and we get 10. So this whole thing is equal to 10 times the square root of 6. And we have the area, this. So this is our answer of MNO. Thank you for watching Kid2Kid Tutorials. And if you like our videos, please share, like, and subscribe. Thank you.